You know, when you walk into a massive modern skyscraper, one of those really sleek glass and steel monoliths, there is this overwhelming expectation of engineering perfection.
Oh, absolutely.
Like you see the massive steel beams holding up the roof and the elevators gliding silently of 100 floors. You see the perfectly calibrated lighting.
Yeah, it projects this illusion of total mastery over nature.
Exactly. You step out of a sweltering summer afternoon or, a freezing winter night, and suddenly you are in this perfectly climate-controlled bubble. It feels absolutely mathematically pure, like every single variable is completely under control.
Right, because you are physically shielded from the elements, the temperature is perfectly regulated, and the environment feels completely insulated from the chaos outside.
But then you start looking into the actual mechanics of what is keeping you alive inside that pristine bubble,
Yeah.
specifically the air you are breathing. And suddenly that illusion of engineering perfection starts to look incredibly murky. I mean, the math just doesn't add up the way you assume it would.
It really does.
Today, we are bringing you on a deep dive into a really fascinating set of blueprints, notes, and philosophical discussions from June 2026. And these sources, they analyze a fundamental, almost shocking disconnect between how our buildings are engineered and how our human lungs actually work.
Right, and the overarching mission of our analysis today is to uncover that massive disconnect. We really want to understand the physics of why traditional air conditioning systems function the way they do, and to explore a completely new architecture for how we breathe indoors, which the sources refer to as the little heaven concept.
Okay, let's unpack this. Because to really understand the hidden problem with our indoor air, we have to start with, well, a math problem.
Yeah, a very revealing math problem.
It's a surprisingly simple equation that reveals a massive flaw in how the entire commercial building industry calculates what they call fresh air.
Right, so let's look at the baseline numbers that govern almost every modern commercial space you step into. The industry standard dictates that a building needs to supply somewhere between 20 to 40 cubic meters of fresh air per hour per person. Okay, to break that down, it's about 8 to 10 liters of air per second for every human in the room.
So under this standard building math, if you have a mechanical system pumping out 100 cubic meters of air per hour, the engineers will tell you that it supposedly only supports about 2 to 4 people.
Exactly. Maybe 3 to 5 if we, average it out.
Right.
Now compare that to actual human biology. The source material lays this out incredibly meticulously. A resting adult, so someone just sitting at an office desk or sleeping in a bedroom, only breathes about 6 to 8 liters of air per minute.
Wow. So when you scale that up, the gap is just astronomical.
It's massive.
Over a full 24-hour day, a person only breathes about 8 to 12 cubic meters of air in total. And when you are sleeping, your respiration drops even further, right? Down to just 5 to 15 liters per minute.
Yeah, which is a mere 0.3 to 0.9 cubic meters per hour.
That is wild.
A human being requires, at absolute maximum, about 1 single cubic meter of air per hour while resting. Yet the building is mathematically designed to aggressively pump 20 to 40 cubic meters per hour for that exact same person.
So a 40 to 1 ratio.
Basically, yes.
1 cubic meter of actual lung capacity versus up to 40 cubic meters of mechanical airflow.
Yeah.
Why is there such a massive discrepancy in the blueprints? Like, what are they doing with all that extra air?
Well, what's fascinating here is that the traditional engineering mindset isn't calculating what a human actually breathes.
Wait, really?
Yeah, they aren't looking at the biological capacity of your lungs at all. They are calculating the speed at which pollutants accumulate in a given volume of space.
Oh, I see.
We are talking about the buildup of carbon dioxide from our exhalations, but also the volatile organic compounds, the VOCs that are constantly off-gassing from the office furniture or the glue in the carpet, the paint on the walls.
Right, and human body odor and the moisture we constantly release into the air, too.
Exactly. The traditional HVAC goal has never been to provide pure, targeted breathing air directly to your nose. Their goal is purely dilution.
Dilution.
Yes. They treat the room as a giant sealed container of slowly accumulating toxins. To keep the air from becoming toxic, they have to constantly water down the entire volume of the room.
So what does this all mean for you, the person just sitting there breathing? It's basically like sitting down at a nice restaurant and ordering a normal glass of drinking water.
That's a good way to look at it.
But instead of bringing you a glass,
Right.
the waiter brings out a massive industrial fire hose and starts blasting the floor, hoping that a few drops of clean water will eventually splash up into your mouth.
Right, exactly.
They're secretly trying to use your biological need for water as an excuse to dilute a muddy puddle covering the entire dining room floor. You just wanted a sip of water, but the system is using your request to clean the whole room.
Yeah, the mechanism of dilution requires exactly that kind of overwhelming volume. I mean, you are asking for a precise biological necessity, pure air for your respiratory system. But the building responds with an industrial volume of air meant to wash the entire architectural space. Because these traditional systems are focused on managing the entire room rather than feeding your lungs directly, they rely on an engineering logic that fundamentally compromises the purity of the air you take in.
But if dilution is so terribly inefficient for our lungs, why did the smartest engineers of the 20th century build our world this way?
That is the big question.
Because I always assumed that central air conditioning worked by just constantly bringing in massive amounts of fresh air from outside to replace the bad air inside. Is that not how it works?
No, and that is a very pervasive misconception about building mechanics. Traditional commercial HVAC does not use massive amounts of fresh air to dilute dirty air. Doing so would waste just an astronomical amount of energy.
Because of the thermal cost.
Exactly. Imagine it is 95 degrees and incredibly humid outside.
Ugh, miserable.
Right. If a skyscraper constantly pulls in massive volumes of that 95-degree outside air, the internal chillers have to work incredibly hard to cool all of that new air down to 70 degrees and strip the humidity out of it.
Yeah, that makes sense.
If they immediately exhaust that cooled air back outside a minute later just to pull in more 95-degree air, the energy bill would bankrupt the building owner in a week.
So what is the actual secret formula running inside the ductwork then?
The formula for traditional central air conditioning relies heavily on recirculation.
Recirculation, yeah.
You take the dirty, ambient indoor air and you repeatedly loop it back through the building. And to that recirculated air, you add a very tiny supplement of fresh air from outside.
Just a tiny bit.
Usually just the bare minimum required to meet legal building codes for carbon dioxide limits.
Wow.
Yeah. And then you run that blended air through some coarse filtration to catch the largest debris, and you tightly control the temperature.
So the end result is basically a room where humans can temporarily sit and work without immediately noticing that the air is actually stale and dirty.
Pretty much. The strict priorities of HVAC engineers from roughly 1960 to 2020 followed a very specific hierarchy. Priority number 1, maintain thermal comfort. Keep the temperature and humidity perfectly pleasant.
Okay.
Priority number 2, save energy. Do not waste the cold or hot air the building has already paid to create. And priority number 3, minimum ventilation. Just keep the carbon dioxide levels low enough to keep people from feeling drowsy or violating code.
Here's where it gets really interesting, though. Because hearing all this, the immediate instinct is to villainize those engineers.
Right, to call them cheap or perilous.
Yeah, to assume they built these malicious or negligent systems that prioritized money over human health.
Yeah.
But the sources we are looking at are very clear that we shouldn't do that.
No, we definitely shouldn't.
And honestly, looking at the history of architecture, the sources make a brilliant point. These engineers were actually incredibly successful at what they set out to do.
They really were. They delivered absolute triumphs of their specific era. I mean, they solved the exact problems they were hired to solve.
Without their intense focus on energy efficiency and basic thermal comfort, the modern world literally wouldn't exist.
Exactly.
The sources specifically highlight megastructures like Taipei 101, the Empire State Building, the Shanghai Tower, and the Burj Khalifa.
Right.
These immense vertical cities could not operate if they had to constantly pull in, filter, and condition 100% fresh air for tens of thousands of occupants. They would be unlivable energy black holes.
They absolutely would.
The engineers achieved a miracle of modern architecture by finding the perfect compromise between energy and survival.
The source material really stresses this fairness. Central air conditioning is undeniably one of the most successful inventions of the modern age. But the vital nuance here is understanding its core philosophy. Its goal was to allow 1,000 people to work inside a sealed glass box without getting too hot or too cold. It was, at its core, an energy-saving comfort project. It was never designed to be a longevity breathing project.
An energy-saving comfort project. not a longevity breathing project. That is a huge distinction.
Yeah.
So we are breathing the exhaust of an economic compromise.
Exactly. The traditional system treats the air in the building as one giant shared pool for 1,000 people. It manages the temperature and the dilution of the pool as a whole. It does not focus on the individual lungs of the 1,000 separate people swimming in it.
Okay, so if the central system is constantly recirculating the exact same air over and over to save on chiller costs, and it's only providing the bare minimum of fresh air to meet the legal code for dilution,
Right.
where do all the remaining ultrafine particles go? Like, what happens to the aerosols, the microplastics, the lingering viruses, and the long-term chemical toxins that those coarse industrial filters miss?
Yeah, that is where things get grim. The source material introduces some genuinely chilling language to describe this phenomenon.
Yeah.
When you look at the long-term life cycle of a sealed building, the authors describe them not as modern sanctuaries, but as toxic buildings or life shackles.
Life shackles.
Yeah.
That feels like an incredibly heavy phrase for an office building.
It sounds dramatic until you look at the physical evidence hidden inside the guts of an aging building. To understand where the particles go, you have to look at the physics of airflow over a 10 or 20-year period.
Okay, lay it on me.
Well, a complex set of mechanical factors are constantly at play inside the ductwork. You have continuous airflow friction against the galvanized steel. You have constant microscopic condensation from humidity changes as the chillers cycle on and off.
Right.
And the architecture of the ducts themselves creates traps. When air rushes through a duct and hits a sharp 90-degree turn, it creates a swirling vortex.
With the little cyclone inside the pipe.
Exactly, a low-pressure eddy where the air velocity suddenly drops. And without velocity to carry them, microscopic particles just drop out of the airstream.
Wow.
Combine that with the surface static electricity generated by years of continuous friction, and these particles essentially glue themselves to the interior walls.
So, over decades, these massive air delivery arteries basically turn into massive dust collection tubes.
Oh yeah. Maintenance engineers find incredibly heavy, cement-like accumulations of grime, heavy metals, and toxins. It builds up thickest on horizontal pipe runs, sharp elbows, and in the wide junction boxes where the airflow slows down.
The sources have this one observation that is so stark it made me stop reading just to process it.
Which one?
It simply says, the dust inside the air duct didn't fall from the sky. It was originally in the air you breathed.
Yeah, that line hits hard. We tend to look at a photograph of a filthy, neglected air duct and think about it merely as a maintenance failure. We rarely make the biological connection that every single particle of that thick, gray dust was suspended in the ambient air. It was floating through the occupied space, being inhaled and exhaled by the occupants for years before it finally snagged on the metal.
Wait, I have to play devil's advocate here for a second.
Sure.
Because anyone who has looked at a modern building spec sheet or purchased a high-end air purifier is going to point to the filtration data.
Yep, the lab tests.
Right. Don't we have commercial HEPA filters? Don't we have rigorous lab tests and certifications proving that the air coming out of these systems is 99.9% clean? How does that square with 20 years of grime in the ductwork?
Well, the author of these notes is heavily skeptical of those exact lab tests, and they explain the mechanical failure behind them. There is a massive difference between a pristine 5-minute test in a laboratory and the messy fluid dynamics of a functioning commercial building.
Because the lab doesn't account for time and degradation?
Exactly. Filters work by creating resistance. They force air through microscopic interwoven fibers. But air, from a fluid dynamics perspective, is fundamentally lazy.
Lazy air. I love that.
It always seeks the path of least resistance. So in a lab, the filter is perfectly sealed. But in a massive sealing unit that has been rattling and vibrating for 5 years, the rubber seals degrade, the housing warps slightly.
And the air just bypasses the filter entirely.
Yes. Once the filter gets slightly clogged with dust, the resistance increases. The air simply slips through the microscopic gaps around the edges of the filter frame. You can wave a lab certificate around all you want, but the physical evidence over 20 years proves the 5-minute lab specs are incomplete.
Yeah.
The filters do not catch everything.
Okay, so if the mechanical filters fail and the ducts only catch a fraction of the debris through static friction, the remaining pollutants are still circulating.
Yes, they are.
Because the building's mechanical systems do not capture everything, something else has to. And what is the one machine in the room that is constantly pulling air in, filtering it through incredibly fine, moist membranes and trapping toxins?
If we connect this to the bigger picture, the answer is the human body. your lungs, your bloodstream, your internal organs. We become the final, most efficient filter for the building.
That is deeply unsettling.
It is. This is the origin of what the sources call the human air purifier concept. Because the building recirculates dirty air to save energy and relies on an inefficient dilution strategy, we are quietly drafted into doing the heavy lifting. We clean the recirculated air with our bodies.
We're functioning as the biological filter for an economic compromise.
Precisely.
That completely flips the script on how you view sitting at a desk all day. If relying on a building's shared HVAC system turns our lungs into the final filter, how do we engineer our way out of it? It feels like the only solution is to stop treating the room as one giant mixing bowl.
That is exactly the pivot the sources make. They propose a completely new design philosophy called the Little Heaven architecture.
Little heaven.
Yeah. Specifically, they detail two mechanical applications: the sleeping little heaven and the mobile little heaven.
The name Little Heaven is such a deliberate contrast to a dilution zone. How do these systems fundamentally differ from the central AC we've been talking about?
The little heaven concept completely abandons the traditional goal of ventilating the whole house or diluting the whole room.
Okay.
Instead of managing the volume of the architecture, it asks a targeted biological question. What does the human nose actually need right now?
And the answer relies on a strict division of labor.
Exactly. The traditional system tries to make one massive machine do absolutely everything. It expects the central roof unit to provide oxygen, dilute pollutants, manage odors, control moisture, and heat or cool the air.
This is a jack of all trades stretched too thin across an immense volume of space.
Right. So the Little Heaven architecture splits the job into two distinct, highly specialized roles.
Let's break down role number one.
Role number one belongs to the fresh air system. In this new architecture, the fresh air system is only responsible for the basic biological gas exchange.
Just the oxygen.
Yes, its entire job is just to supply pure oxygen, remove carbon dioxide, and bring in a precise measured amount of fresh air from outside. It is no longer responsible for cleaning the room or diluting the carpet fumes.
But wait, if the fresh air system is solely focused on the oxygen supply, who is handling the particulate matter? Who is cleaning up the VOCs, the dust, and the circulating odors?
That falls to role number two, which is handled by a dedicated indoor purifier, the human Little Heaven.
Got it.
This is a localized, highly targeted system. Rather than trying to clean 1,000 square feet of office space, a mobile Little Heaven sits on your desk or functions as a targeted ceiling drop, creating a continuous, hyper-localized loop of clean air immediately around the person.
It creates a localized breathing zone.
Exactly. The physics behind it rely on laminar flow. The sleeping Little Heaven, for instance, isn't just a fan blowing in your face. It's designed to create a precisely calibrated, positive pressure zone that gently cascades over your bed.
Oh.
It creates a physical, invisible barrier of purified air that actively pushes the room's ambient, dirty air away from your face while you sleep. Its only job is to aggressively and repeatedly clear out particles, aerosols, and toxins in a 2-foot radius around your nose.
The math on the efficiency upgrade here is incredible.
Oh, it's night and day.
By dividing the labor, you completely change the mechanical capacity of the hardware. Earlier, we established that a traditional 100 cubic meter per hour fresh air system supposedly only supports 3 to 5 people because it has to act like the fire hose washing the muddy floor.
Right. But when you stop using fresh air to dilute the entire room and you let the Little Heaven purifier handle the localized cleaning, that exact same 100 cubic meter machine suddenly has vastly more biological capacity.
Because now it is only tasked with supplying oxygen.
Exactly. According to the blueprints in the sources, it goes from supporting 3 to 5 people to easily supporting 8 to 12 people for short-term use.
That is a massive jump.
It is, and even if you want to maintain a highly comfortable, ideal safety standard, which they define as 10 to 15 cubic meters per hour per person, that exact same system perfectly supports 6 to 10 people.
You literally double the efficiency and capacity of the central machine just by letting it do the singular job it was meant to do.
This raises an important question, and it really is the crux of this entire deep dive. When you let the fresh air system handle the breathing, and you let the localized Little Heaven handle the particulate cleaning, you aren't just changing the airflow physics.
Right.
You are fundamentally shifting the engineering goal of the space. You transition away from asking, how do we make a large building economically comfortable, to a much more vital mandate. How do we ensure this specific human being is breathing perfectly clean air?
It changes the entire relationship between the human and the architecture.
Hmm.
It means we stop treating human beings as just another variable in the building's waste management system and start treating the human respiratory system as the primary priority.
To synthesize what we've uncovered from these 2026 sources, traditional HVAC systems are an absolute marvel of energy efficiency and thermodynamics. We owe the modern vertical skyline to them.
Without a doubt.
But they were never designed for human longevity. Their goal was wide-scale dilution and recirculation. True clean air requires shifting our engineering focus away from managing the vast volume of a room and zooming in on the actual mechanics of the air entering our noses. By utilizing targeted, localized purification alongside a dedicated oxygen supply, we finally ensure that our lungs don't have to do the dirty work for the building.
It certainly makes you view the indoor world differently. I know that the next time you look up at a quiet ceiling vent in a sleek, modern office building, you are going to remember exactly what that system is and isn't designed to do. It might be keeping you perfectly cool, but you might also be acting as the room's biological filter.
It is an invisible reality we all walk through every day, entirely unaware of the physics at play.
And we want to leave you with a brand new thought to mull over, building on the mechanisms we've discussed today. We've just spent this time learning how massive indoor air systems quietly use the human body as a final filter to save energy and save money.
Right.
It makes you wonder, what other invisible large-scale systems in our modern daily lives are designed with this exact same compromise?
That is a fascinating question.
Think about our municipal water grids. Think about our global food supply chains, or even our digital information feeds. How many of those sprawling systems are designed primarily for efficient circulation, quietly relying on our physical bodies and our minds to filter out the toxic byproducts, simply because it's cheaper for the system to let us handle the waste?
When a vast system prioritizes economic efficiency above all else, the individual invariably becomes the filter.
So the next time you feel like everything around you is engineered to pristine perfection, ask yourself if the math really adds up for you, or just for the machine. Keep wondering, keep questioning, and we'll see you next time.